Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows.
Today, we're here to talk about a networking incident that impacted both of our Azure regions in South Africa last month, from the 14th of March. And we've got a few speakers that are going to be able to talk us through it.
Super. First, we have Dave Moltz, our technical fellow and corporate vice president of our Azure networking team.
We also have Frank Ray, our partner and head of our hyperscale network connectivity.
We also have Mike Ziok joining us, our partner director from Service Engineering, Microsoft 365.
Thank you all for being here today. I'm really looking forward to talking about this incident and to figuring out some of our learning. So, Dave, maybe we could start with you. Would you walk us through at a high level kind of what happened here? I understand this was a broader continental issue than just an Azure-specific thing.
That's exactly correct. This is an issue impacting the fiber cables that provide connectivity to our South Africa region. In this case, Africa is largely supported by fiber cables that run under the ocean on both the west coast of Africa and the east coast of Africa. These cables provide connectivity not just for Azure, but essentially all internet service providers that operate in the southern parts of Africa. In this case, Microsoft, we design our wide area network for resiliency. We expect that there are going to be failures in the fiber plants. These are cables. They're not very big. They are out there in potentially hostile environments. And we know that they are going to be damaged or disrupted for a variety of events. For that reason, we currently had, or at the time of this incident, we had four-way redundancy. So basically the internet traffic that's going in and out of the South Africa regions, it has four different paths that it could take. These are physically diverse, so that as issues happen to one, we have resiliency, enough capacity to carry the traffic on any of the others. Essentially what happened through a series of fiber cut events over the course of several weeks, we found ourselves going from four-way redundancy down to not enough remaining capacity to carry all of the network traffic in and out of our South Africa regions without impact. The Azure networking teams, together with all the other Microsoft teams, then responded to this, basically finding ways to reduce the amount of traffic that was flowing across these fiber links, basically all the discretionary traffic, all of our internal replication traffic that is not time sensitive. We shifted that away or delayed it completely. We also then scrambled to turn up as additional capacity that we could in order to have enough capacity to carry your traffic, our customers' traffic, at the highest levels of quality across the network. Did take us a while to get back into that restored state. Over the course of this web stream, our goal is to tell you exactly what happened, what the sequence of events was, as well as talk about some of the other mechanisms that we are putting in place and some of the process improvements we're making to reduce the probability of this kind of thing happening again anywhere in the world.
Super. Thank you very much, Dave. Frank, maybe I can turn it to you. I remember the last time we were talking, you told us that fiber cuts are a dime a dozen. They're quite common, and the cloud pretty much is resilient enough, and we repair them quickly. A subsea fiber cuts any different? How does that change the game?
And would you also walk us through the different kind of impacts of what caused these fiber cuts on both the East Coast and West Coast, as Dave alluded to?
Yeah, thank you guys. So I'll start off by saying what makes it different. So really, at the end of the day, the difference in the subsea cable market is really about the time to repair. So you have to think about, these are cables that are sitting at the bottom of the ocean. In many cases, they're thousands of kilometers away from any kind of a port. There's a small number of ships that actively go to repair these. And so if you think about, the cable cuts that happened on the 14th, they happened somewhere off the West Coast, near Ghana, in that part of the West Coast of Africa. And there were ships that were sailing from Cape Town to go and do the repair. So just the time alone for the boat to make it to the location where there was the fault, that is a matter of days. So the real difference here, aside from the technology that's used, is the time to repair. A terrestrial cable mean time to repair is anywhere between 4 to 8 hours, whereas a subsea cable is measured in weeks. And so what happened in this incident, as Dave mentioned, we have cables that serve our South Africa regions on the East Coast and the West Coast. The East Coast cables were impacted when a ship traveling in the Red Sea was damaged, and the ship was then abandoned and left with its anchor, but high winds and high seas pushed that ship along and dragged its anchor along the ocean floor, or the sea floor in this case, and then hit those cables. And the cables that were being used in the Red Sea also served the east coast of Africa. And on the West Coast, there was a seismic event that happened off the West Coast that ended up impacting multiple cables there as well. So it was quite a serious set of events.
Frank, I have a question. Please, can you humor me? When we think about a cable cut underneath an entire mass of the sea or the ocean, how do we know where the cut is? I mean, I assume they're not looking around for this cut. I'm just interested to know about how we can identify them.
Yeah, so the electronics that are used to power and transmit data over the system, they send signals back and forth as well, and so we can use these signals to see how far they go and try to narrow down the location of where a cut can be.
Got it. We're not playing hide and seek on the ocean. I did want to clarify, I didn't mention in the introduction, I want to remind customers who are watching that we have the Q&A panel available. So on the right-hand side, you can open up our question and answer panel. We've got subject matter experts from our networking team, from our service teams, ready to answer any follow-up questions. So if you're interested in anything that Dave or Frank or Mike mentioned today, feel free to throw a follow-up question in that Q&A window, and our experts will help to point you in the right direction. So Frank, Dave mentioned, this repair work and some new capacity. Are you able to give us an update on each of those? So how are the repairs going? You mentioned it would take some time. And then what are we doing on some new capacity augments to help kind of de-risk the region?
Yeah, so as Dave mentioned, we have four-way resiliency going into South Africa, and the region was designed as a three-failure mode design. That means that 3 of the 4 connections can go down at any one given time, and the region would stay up. In this case, we had effectively a 3.5 failure design, because on top of the cable systems being cut, we also had a line card issue that was impacting the added headroom that we needed and what triggered the congestion. And so in order to repair this, what we did over the weekend during the cable cut, we had already triggered augments to start prior to these cable cuts. And that's what also helped us to react as, in the way that we did. But we did triple the overall capacity into the region and put a new diverse path on the West Coast serving South Africa into service over the course of the weekend between the 14th and the 18th of March. In addition to that, we are in the process of expediting a 5th path into the region that would go from Johannesburg up into our region in UAE to serve as yet another path to add additional resiliency into South Africa. On top of that, we have some investments that are already been in flight for some time now that we're looking to pull in as well, where we are investing over $100 million to serve our South Africa regions for our WAN capacity in Microsoft-owned capacity. So some of the newer cable systems that are being built to serve South Africa, we are going to have Microsoft capacity with our own equipment on that. Which will add even more headroom, give us lots of runway for years to come from a capacity perspective, but also allow us to act more nimble and a little bit quicker, because when we have situations like this, and they will occur again, we will then have our own capacity that we can then shift around on by ourselves on our own equipment and not have to rely on third parties. So we expect that this will give us a little bit more nimbleness and allow us to react even quicker to the needs of the network.
Super. I was going to ask a question for Dave. Dave, obviously we have our network, we have our own stuff, as Frank was talking about, and we share our network, or we lease it with other people. Do we have any learnings around how we accelerate some of the augmented needs? When it's an urgent need to get additional capacity, because you mentioned in the repair items, how are we accelerating this need?
Well, great question. Let me first step back and talk about what is our augmentation list. So as part of our network management, we are continuously running simulations of what would happen if this set of stuff broke. So we have an entire system and team dedicated to running these simulations of network failures under the current traffic load and the peak traffic loads that we expect over the course of weeks and months, so that we know, hey, if this series of failures were to occur, we would not have enough capacity to be able to carry that. Those simulations, as I say, are ongoing and looking not just with current traffic load, but also projected peaks. Anytime we detect a situation where an expected series of failures would result in us not having enough capacity, that triggers what we call our urgent augmentation process. Essentially, we create a list of pathways in the network, segments they're called, where we need additional capacity. Then coordinating across Microsoft, the networking team, along with our finance teams and the folks who actually go and acquire fiber or the rights of way necessary for us to build fiber, we all lean in and then start construction of new paths that'll give us enough capacity to survive those potential fiber failures. In this case, when the first set of fiber cuts happened on the East Coast paths of Africa, our simulations did identify for us that there was a potential risk that if there were additional failures, we would run out of capacity. So that then triggered this urgent augment process, spinning up a bunch of things that then led to us being able to deliver new capacity, basically get more capacity on an additional cable system far earlier than we would have otherwise, because as Frank alluded to, it does take real time to add capacity to existing fiber paths. We are, of course, looking for ways that we can accelerate this even more and making sure that inside that urgent augment list, we're calling it what are true, red alerts, where we absolutely need to pull out all the stops to get that capacity in earlier. And so that's something that we're doing to, again, proactively put enough capacity and redundancy in our network in order to be able to survive failures of any kind of equipment that makes up that network. There's also a bunch of work that we're doing actually more reactively. So as part of our network management systems, there's also a real-time component called our bandwidth broker. Essentially, as services that run over the Microsoft wide area network exchange data, they talk to the bandwidth broker to get a lease to capacity to be able to send traffic across the network. What that means is that by adjusting the configuration of our bandwidth broker, we can shift which services are going to get capacity on that network so that whenever there is a congestion crisis, whenever there is not enough capacity, we can make sure that that capacity is going to the services that most need it in order to give the best possible customer experience. We're onboarding more services at Microsoft onto that bandwidth broker system, making it faster in terms of its ability to react, and now working together with how we can fail over our services. Basically, our services themselves are deployed in multiple regions all around the world so that we can make good decisions about where we're going to serve our customers from, together with the knowledge from bandwidth broker about where there is capacity on the network, so that together services and traffic are deployed in the way that's going to give the best customer experience.
That's cool. Thank you very much, Dave. And lastly, Frank, I noticed that during the time we had a lot of congested traffic, and one of the actions that we took was to take Lagos away from being an edge site so that it could free up capacity. Did that have any impact? What was the impact of taking Lagos away from being an edge site?
Well, we did that because firstly, we had to do that because of this line card issue that we had that reduced the headroom. However small this reduction it was very, very impactful. And so to compensate for this, we did take capacity from Lagos. We took all of that capacity, essentially taking our Lagos edge offline. The impact to this was that customers in Lagos that were looking to reach Microsoft services, they would see their traffic route via a third-party ISP to another place where we interconnect with that ISP. And then it would have entered our network. So rather than entering our network in Lagos, it would have come if we have a connection with an ISP in London or in Frankfurt or anywhere for that matter. And that's how it would reach our services and then return back, right? And so then when we go and repair all of the cables and restore everything to pre-incident production state, we will bring Lagos back online locally, and customers will see their traffic enter the Microsoft network there locally in Lagos.
Got it. Thank you very much for explaining that to us. It's great to hear kind of what happened from a networking perspective, as well as what we're doing on these repairs and augmentations, and as Dave mentioned, to kind of accelerate things moving forward. Mike, I'd love to turn to you, because I understand that this outage really impacted Microsoft 365 as well as Azure services. And I wondered if you could start us with a bit of a high-level overview of how this hurt Microsoft 365 customers. And I understand that varied by service.
Yeah, it depends on the service. So in the African region, we have data locality capabilities. So for example, SharePoint OneDrive has data located there, and to a large extent, if you were connected within the region, you were okay. If we move to email, email is largely delivered from there, but we also rely on our filtering services, which are outside of region. And so some customers would have seen, for example, mail queuing and mail delays as mail was being filtered coming back into the service. Now, we're making some changes in that regard as a part of just learnings from this and our continued investment and expansion in the region to create stronger and stronger capabilities within region. Finally, teams saw some various impact as well based upon the fact that we have some capabilities within region and then other capabilities that are delivered external to region and communicating back and forth. There we also have some further investments going on to bring the capacity, more capacity in region. Largely what we want to do is we want to be able to give our customers sort of the best of both worlds, which is if you're within a region, we want the service to be successful regardless of whether there are connectivity issues outside of the region. But we also want individuals that are connecting to and from to not necessarily be affected by an issue that may be local to that region. And so ultimately, we're looking to balance those and deliver on a promise of sort of capability regardless. And then, from our side, we certainly partner heavily with the Azure networking team, who just does an incredible job in terms of managing through these issues. The bandwidth broker capabilities, being able to adjust and manage traffic is just, for me as being a technologist, is an amazing sight to watch as they work through some of these complex issues.
Super. Thank you, Mike. Mike, one of the things that you mentioned was super interesting. It was you want the service to work, but if it has to make a call outside of the region, in this case, then we ran into issues. Is the design for M365 service to say, hey, I need to make a call outside and I can't do that, and it might be the status icon on Teams or something? Does that mean the service should be continuing, but this feature will be degraded, and there's a graceful degradation with the core services working?
Yeah, there are some features. Certainly, we prioritize something like voice as having a set of capabilities versus, I don't want to diminish the importance of chat, but if voice being real time, you want to have uninterrupted. So there's work that we're doing to ensure that we have really strong protections in place for that. Certainly, there are going to be scenarios if an individual is connecting from outside the region back to that location. We obviously need network capacity to be able to carry it. But what we want to do is we want to minimize the amount of traffic that has to go to and from as part of sort of its own brokering system of communicating back and forth. We'd prefer that to happen within region where possible. Our priority is just to make sure that we're delivering on our customer commitments for where customers require data localization to meet regulatory requirements or otherwise, that their data is always housed within the region, and then we're communicating to other services. Those are the services that we're looking at. How do we better deliver resiliency to protect against a sort of intercontinental type issue that we ran into?
Yeah, that's a really good point, and I want to double click on each of those because you touched on it, but this is something that a lot of customers reading the post-incident review, were surprised to hear, which is, hey, I thought I was just accessing services within South Africa. I'm hearing about these problems, getting beyond Africa from the fiber and the subsea cables, but that's not me. I'm just trying to access South Africa. So can you talk us a little bit about customers who had troubles, even though they thought they were accessing services within Africa or that didn't require that kind of bandwidth to leave the African continent?
Yeah, there's a lot of depends in that, David, but I'll give an example. So if you're managing your own MX record, for example, we may route your traffic outside for mail filtering, right? Versus if you're doing just internal organizational mail. If that all flows through your own instance, then we ultimately are filtering that mail, and the filter is occurring outside of region because it's just an ephemeral sort of transaction just to make sure that the email is clean, and then it's routed back. Well, if that email can't get out or email can't get back in, then even though your email may be hosted in region, you may have seen impact because mail filtering is not fully within South Africa. It's delivered out of Europe in cases as an example. So hopefully that gives an instance of example that would apply in a particular case where a customer may have seen impact. Some customers didn't see that level of impact. And then, as I mentioned, with Teams, there is now a concerted effort to bring more capability within region. We have a very distributed architecture. Some services are within region. We're very committed to the South African region itself. And so we're bringing more capacity in so we can do more processing within region so we can have better protections for this type of issue as well.
Super, Mike. And tell us, when we're faced with a situation where we have to think about failing out or calling externally, how do customers' data residency requirements impact decisions or go on?
Well, I mean, ultimately, in a regard, the data residency requirements are sacrosanct. So we're not like replicating a copy of email. So if a customer has data residency within South Africa, we've got 4 copies of it across 2 data centers, and then we're replicating inside of those data centers to provide sort of 4-way replication. Now, we're not making a 5th copy of that and putting it outside of the region because that would violate our commitment of data residency in that particular case. But where we have the capability to be able to route outside of the region, for example, to deliver sort of a transactional function with data residency not being in question, that's always something that's not a bad thing to have in place, right? So if a user is connecting from Europe back to South Africa for email, for example, so it's a South African company and their data is located in South Africa, we want to provide a good experience by rendering web components and so on and so forth out of Europe, as an example, doing the authentication and then just delivering on the back end the email that's within region itself. So we're doing the work to make sure that we sort of deliver the best of both worlds, which is the data residency commitments, but still actually being able to give the best performance for users connecting in.
It's great to hear. I'm glad that we take that into account and kind of only move the things that can be moved. Last question to you, Mike. I know the Microsoft 365 had your own very detailed post-incident review. Are there any other learnings or repair items that you want to touch on from any of the Microsoft 365 services or anything kind of high level?
Well, I mean, there's always an architectural introspective that we take. Coming out of this event, we identified some components that we could move within region that we certainly expect and look to the network to be performant, but we also need to make sure that we design for the things that we can't account for. And so that was a learning from this particular case. And again, the South African region is I don't want to say new investment, but it's relatively new in terms of the amount of investment. And so we're continuing to expand our capacity. And what this event showed us is what to prioritize in terms of what do we bring in and expand within the region. Data residency is job number 1. Then routing isolation is going to be job number 2. That the transactions can actually stay within region as well. And so we took those as a set of learnings. Those are called out in the post-incident report. Teams is an example of that.
Got it. That's a great example. Thank you. Thank you for talking us through the M365 impacts. Now, I'm mindful of time, but I've saved one last question for my co-host, Sammy, over here. Sammy runs our Azure Incident Communications team. So I wanted to kind of understand, how did we do from a comms perspective? We try to keep customers up to date. How did that go during this networking outage?
There were good things and bad things. Starting with some of the not so bad things, we managed to communicate to everybody in the region. We had a message up on our public status page, but more importantly, we were communicating through Azure Service Health very quickly. We did tell customers this is a serious issue. They should find workarounds, or they should fail out or invoke some sort of BCDR solution. So we're able to do this. And then where we could, we offered ETAs. And we said, we think it's going to take 3 hours, 5 hours, 12 hours. A couple of times we were a little bit off, but providing that at least gave customer a sign or an indication on where we were progressing and how we were progressing. We were really pushing for transparency so that customers could really take our communication and make business decisions. The places where it didn't go so well, first of all, our message was on our public status page for 3 days. And as we've seen in the PIR, as Dave and Frank have spoken about in depth, the issue lasted pretty much 24 hours or just under 24 hours. So having that message on there as a just in case, we were slightly apprehensive that potentially as South African traffic would peak during Monday morning, we may be in a state, so we were monitoring, but I think we should have taken it down so the customers have understood, like we've got things under control and there's a little bit of monitoring there, but we kept it up there longer than we should have. Our brain, our automated communication system fired some alerts and we had some other services speaking, but essentially there were some customers who would have seen multiple tracking IDs and the tracking IDs appear as disparate. Now they say the same thing, but the idea of having separate reference IDs without it being nested is confusing and at the very least noisy for some customers. And that's work we need to go and do so we can make sure that these are nested and they're all connected to the same one. The third one, which is interesting, is, as Dave mentioned, this was a broader issue, and we wanted to gesture to the idea that this is broader, that it's not simply the Azure that's impacted, but the impact is broader. There's many ISPs and internet providers that are impacted, but we spoke about other cloud providers being impacted. And it wasn't our intent to communicate about other cloud providers. We were simply trying to gesture to a broader issue. And I think we have some learnings and repairs to go on from that.
Great. So not just technical learnings in terms of how we add capacity more quickly, but also some learnings around communications and collaboration. So I'm glad we mentioned that. Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.